Welcome to College Algebra. We're going to do 1.8 mathematical modeling. And modeling is kind of a fancy word for kind of trying to figure out an equation that helps you predict something, or an equation that's helpful to use for a certain purpose. Okay, so we're going to do some modeling today. And I wanted to start with kind of just a basic situation where it would be nice to have an equation to help you. So it says you've got a job here. Your wages vary depending on what? Okay, so you're working at McDonald's. How do you know how much your wages are going to be? Well, it all depends on how many hours you work. Okay, so write a model that represents this. So basically, my wages are going to equal whatever my rate is. Like if I get paid $8 an hour, then that's what my rate is, times how many hours I work. All right, so that's a simple little equation. Now, the thing is it's not incredibly helpful, so we need more information. So it says here, if you worked 9 hours and your paycheck was $57.60, could you write a more helpful model? Okay, so basically what this is helping us find is if they tell us we have 9 hours and we know what our paycheck was, we could use those two values to find the rate. So in other words, this is if you don't know exactly what you get paid per hour. Now, of course, you always have to take into account that they take some out for taxes. And so just because you think you get paid $8 an hour isn't really what you're going to end up being paid per hour on a paycheck. So let's figure out, this would be basically your net pay. So if we've got $57.60, and it's going to equal R times 9, and we just divide by 9, basically, it's to find that rate. If I divide by 9, I end up with my rate equaling 6.4, so $6.40 when it's all said and done that I'm getting paid each hour. Okay, so then can we write a more helpful model? Yes. Now instead of putting this R in here, I know what R is equal for me. I'm getting paid $6.40, so let's write a model. The model that we're going to be using is W equals $6.40 times H. And now that you have that, you can actually use it. I used to do this during my lunch hour. I used to go figure out, okay, how much is my paycheck going to be this week? And so I'd have this model like this, and then I would plug in how many hours I thought I was going to get. So in this case, we're going to get 17 hours. So all you do is you plug 17 in for H and see what 1640 times 17 is, and you get $278.80. So that would be my paycheck. That's not right. I typed that in. Okay, that's dreaming right there. Sorry. Let me change that. I put in 1640. That would be a much better job. 640 times 17. All right, $108. All right, so I'm going to get $108.80. All right, so if you notice in that problem, it said it varied with what? Your wages varied with what? So what we're talking about today is variation, and we're setting up equations that have some type of variation. And there's going to be 3 types that we look at. The first one is direct variation, and it is a model that looks something like this. This is the example we just did. It was a direct variation model. And it's very basic. That's all that's going on. If you look at that, if you consider what the graph would look like, basically this is slope-intercept form. But there's no b value. I'm not adding anything, which means the b value would be 0. So on a direct variation model, it's always going to start at the origin and then look something like that. It'd just be a linear relationship. Okay, an inverse variation is more of a fraction. Now, I don't love the way I wrote this. That's just the way I can type it easily, but really I like to show those fractions like this. So this is going to be like a rational expression where you have x in your denominator. And if x is in your denominator and you started plugging in some values, as your x value gets bigger, as your denominator gets bigger, well then the value of y is actually going to go down because that's what you're dividing by. So this is really going to have more of a decreasing look to it. Okay, and joint variation means you have multiple things going on. It varies dependent on several things. This equation right here is a pretty common one for joint variation. This is the interest that you earn on like a savings account. It is equal to your principal, which is the amount of money you put in, times your rate, that's your interest rate, times the time that you leave it in there. So if you had $4,000, let's say, well, how much interest you have is dependent on, or is going to vary depending on what interest rate they give you and how long you leave it in there. So that means you have multiple things that are going on. Okay, so let's practice writing some models. We're going to write a mathematical model for this expression. It says A is jointly proportional to y and c. Okay, A is jointly proportional. So this is going to be the where there's three things going on. And what we always put in here is a k value. Whether it's direct, inverse, or joint, we have this k. That is a constant value. It's going to eventually be a number, but to start with, you just put a k there. And then you put the two things that it's varying with on this example. But you can't forget to leave that k in there, because typically we'll do a little bit more than just write it like this one. Sometimes they give you the k, sometimes you have to go find the k, but you have to leave that place for it. Okay, let's try going the other direction. What if they give us the formula? Could you turn it in to a sentence like this? Can we do that? So our formula here is the volume of a sphere, and we're supposed to write the sentence. Okay, since it's the volume of a sphere, when I write this, I'd like to be kind of specific. Instead of just using A, Y, Z, let's talk about what V stands for. Well, this is the volume. And if you're talking about a sphere, what do you suppose the R stands for? Okay, it's the radius. All right, so let's write this sentence. I would go with the volume of a sphere varies. Now we have to decide what type of variation we have going on. I do see that there's a fraction, but notice that the variable is not in the denominator. So this is not indirect because, or inverse, because the variable is not in the denominator. This 4/3 is just a constant. That's going to be that k value that I need. So let's look at what this is. Well, that's just pi. That's also just a constant. So this 4/3 pi, all of that is my k, because pi is just 3.1416, so forth. So the variable, the only variable I have is the radius. So it's not like I have two variables. So this is not joint variation. This is going to be direct variation. And I just have the one variable. So I'm going to say the volume of a sphere varies directly. Or another word that is used often there is proportionally. You'll see that on several problems. If something varies proportionally, that means directly. With the, and it's not just the radius, it's the radius cubed. So you have to, if you're going to do something to that variable, be sure you express that in your sentence. And then I always like to put in parentheses afterwards and specify what does k equal. So in this case, k equals 4/3 pi. That's what we call the constant of variation. Okay, let's try one more. This last one. Now this one, I don't know what this stands for. It's some physics formula, I'm sure, but I don't know what everything means. So I'll be very vague when I write it, kind of like this first one was, where I'm just going to put in the letters if I don't know what it all means. Okay, so I have this k value out in front. They've got that. I see a fraction, and I have a variable down here. So this is going to be inverse variation because you have the variable on the bottom. But the problem that I have is I also have two variables that are being multiplied. That's kind of like this joint variation. So this is an example that has multiple types of variation going on, and many formulas will do that. So here we go. I'm going to write my sentence. F varies, and I can say, I need to say both of these. It doesn't really matter which one I say first. I'm going to go ahead and say it varies jointly with M1 and M2, and inversely with T squared. And then in parentheses, I'll put K is K, I guess in this case. They didn't give me a number on that one. So my constant of variation is just K in this example. Okay, let's try using these a little bit more and creating some. So here's a classic type of problem that we're going to be working with, which is really more helpful for us to be able to write these models so then we can use this model to determine, like on that earlier one, how much we were going to get paid. So it says determine the constant of proportionality. So I'm going to be looking for K. If X is inversely proportional to the square of Y, when Y is 7 and X is 3. Then write the mathematical model. Okay, there's several things going on here, but ultimately we're trying to write a mathematical model that's going to be helpful. So when I write my final mathematical model, I can't just have a K in it. At that point I should have already figured out what K is and I should have a number there. So that's our first job, determine the constant of proportionality. So let's write this. X is inversely proportional, so X is inversely proportional, so that's a fraction, to the square of Y. Not the square root of Y, the square of Y. And I'll put my K up here. Now, that's the general model, but they give us some numbers to plug in. They tell us that when Y is 7, X is 3. So let's plug that in. And that'll be 7 squared. So with that, we can figure out what our constant of proportionality is. I'm just going to take both sides times 49. That'll cancel out. 3 times 49. So K ends up equaling 147. So once you know the constant of proportionality, then we can go write our mathematical model. So we write this again, but we change the K into a 147. So final answer, X equals 147 over Y squared. Now, many times what they'll do is they'll come back and they'll ask an additional question. They'll say something like this. It'll say, when Y is 7, X is 3, find Y when X is 12, or something like that. So you'll have to do all of this work, but then it's one more thing that you plug in at the end to find some missing scenario. Okay, on this particular example, we just had to find the model, and we've got it. Okay, so one last thing before I turn you loose. If you want to look at problem 1. Or the very first problem on your 1.8 assignment, because that I'm kind of want to clarify what they're looking for on that one. So pause the video, get your book out, get your paper ready to go, and then start it up again, and we'll look at that first problem. It's not number 1, I think it's number 13 that we're looking at, 13 or 14. Okay, so the first problem is number 14. And they give us a table of values, and the directions way up above say, determine whether the variation model is of the form y equals kx or y equals k over x. And then we're supposed to find k. All right, so here's the deal. K is a constant, so it has to stay the same regardless of what's going on. So you're kind of doing something like this. You've got, you're testing, it's either y equals kx, or it's going to be y equals k over x. And what I'm going to do is I'm going to plug in a point, and I'm going to see what happens. So you can pick any of those ordered pairs. I'm going to go with the 5, 2 from the table. So if I put in a 2 for y, and I'm going to put in a 5 for x. Divide both sides by 5, so k is 2/5. All right, if I do it on this side and plug 2 in for y and 5 in for k, I'm going to multiply both sides times 5, so k is 10. I got different k values. All right, but if this is truly a constant of variation, then it shouldn't matter which ordered pair I pick, I should get the same k value. So let's try this again, but this time I'm going to use a different point. Let's do the 10, 4 point. So I'm going to plug in 4 for y, 10 for x, and see what I get. Divide by 10. So k would equal 4/10, but that does reduce to 2/5. Okay, I like that because that's what I had gotten previously, and the constant should stay the same. Look at what happens over here. If my y is 10, and my y is not 10, my y is 4, and then it'll be k over 10, and I multiply both sides by 10, then this time k is equal to 40. Notice that is not what I had earlier. So the constant didn't stay constant, it changed. So it can't be this type of variation. This example would have to be direct variation. So what you're going to do then you're going to test it to see which one of those methods works and keeps the same constant. Then you're going to specify, okay, so this one is going to be direct variation, and your k is going to be 2/5. And that's what they want you to decide. And when it says direct variation, one thing, you can write direct, you could also just write y equals kx is the form. Either one of those, both of those, whatever. All right, go get started. Good luck.